We are afraid of disease. It is a primal fear written into our DNA. We fear the invisible killer that moves from person to person, the virus that replicates, the bacteria that consumes. We lock our doors, we wear our masks, we wash our hands. We try to isolate the healthy from the sick. But in the world of biology, a virus is fragile. It can be killed by heat. It can be killed by soap. It can be stopped by a vaccine. The universe, however, holds a contagion far more terrifying than any plague. A contagion that does not attack your cells but attacks your atoms. A substance so perfect, so stable, and so hungry that a single microscopic droplet of it could kill the entire Earth. It would not kill us by making us sick. It would kill us by converting us. It would touch a rock and the rock would become it. It would touch the ocean and the ocean would become it. It would touch you and you would become it. This is not science fiction. This is the strange matter hypothesis. And if the mathematics is correct, there are bullets made of this substance flying through the galaxy right now, waiting to hit a target, waiting to start a fire that cannot be put out. To understand this ultimate weapon, we must first look at the crude matter we are made of. You, the chair you sit on, the air you breathe, you are made of normal matter, protons and neutrons. If you look inside a proton, you find three smaller particles called quarks, specifically up quarks and down quarks. Nature loves these two. They are the building blocks of everything you have ever touched. They are the Lego bricks of the cosmos, but they are not the only quarks. There are 6 flavors of quarks in the standard model: up, down, top, bottom, charm, and strange. The others are usually unstable. They decay instantly. But the strange quark is different. It is heavier than the up and down quarks. It is elusive. And for a long time, we thought it only existed for fractions of a second in our particle accelerators. But there is a place in the universe where the laws of physics are crushed into a new shape: the neutron star. When a massive star dies, it collapses. Gravity pulls it inward with such violence that atoms are smashed. The electrons are shoved into the protons, turning them into neutrons. The star becomes a city-sized atomic nucleus, so dense that a teaspoon of it would weigh 1 billion tons. In the core of this dead star, the pressure is infinite. The neutrons themselves are squeezed until they dissolve. They melt. The boundaries between particles disappear, and we get quark matter, a soup of free-floating quarks. In this hellish pressure cooker, something alchemical happens. The energy is so high that some of the up and down quarks are converted into strange quarks, and this creates strange matter, a mixture of up, down, and strange quarks. Now here is the terrifying part. Physicists Edward Witten and Arnold Bodmer proposed a hypothesis. They calculated the energy states of this new material, and they found something that should not be true. They found that strange matter might be the ground state of the universe. Let me explain what that means. In physics, everything wants to be at the lowest possible energy level. A ball rolls down a hill. Heat cools down. Everything wants to relax. Normal matter, the atoms in your body, is not at the absolute bottom. It is stable, yes, but it is under tension. It is like a compressed spring waiting to release. Strange matter, according to the hypothesis, is the bottom of the well. It is the most stable substance possible. It is perfect matter. And nature loves perfection. Nature wants to be strange matter. The only reason you are not strange matter right now is that there is an energy barrier. You are trapped in the normal matter state. You are like a ball stuck in a valley when there is a deeper valley right next door. But what happens if the barrier is breached? What happens if strange matter touches normal matter? This is the nightmare scenario. If a piece of strange matter, a strangelet, touches an atom of Earth, it does not bounce off, it interacts. The strange matter is more stable, so it pulls the quarks of the normal atom into its own structure. It eats the protons and neutrons. It dissolves them, reassembles them, and turns them into more strange matter. This process releases energy, heat. Massive amounts of heat. But unlike a fire which runs out of fuel, this fire makes its own fuel. The more matter it eats, the bigger it gets. The bigger it gets, the more it can eat. Imagine a single drop of this liquid falling onto the surface of the earth. It would look like a heavy metallic droplet. It would hit the ground and sink, not because it is heavy, but because it is eating the rock beneath it. It would start a chain reaction. The soil, the magma, the iron core, everything it touches would be transmuted into strange matter. It would release a wave of heat that would incinerate the atmosphere. The earth would not explode. It would simply collapse. It would shrink. The entire planet, all the cities, all the oceans, all the history would be converted into a hot gray sphere of strange matter the size of a soccer stadium. And then it would sit there, radiating heat, perfectly stable, perfectly dead, forever. This is the Ice Nine scenario, named after the fictional substance in Kurt Vonnegut's novel. But Vonnegut was writing satire. Physics is writing a warning. The terrifying thing about strange matter is that it is contagious. It is the Midas touch from mythology. King Midas touched gold and it stayed gold, but if you touched strange matter, you would turn into it, and then anyone who touched you would turn into it. It is the ultimate infection, and there is no cure. You cannot burn it, it loves heat. You cannot blow it up, it absorbs the energy. You can only run. So where is this stuff? Is it locked away safely inside neutron stars? We hope so. The gravity of a neutron star is so strong that it should keep the strange matter trapped in the core. It is a prison for the monster, but prisons break. Neutron stars are not eternal. Sometimes they collide. Two neutron stars spiraling in towards each other, crashing together in a kilonova explosion. We have seen these explosions. We have detected the gravitational waves. When they crash, they spray the insides of the star out into the galaxy. They vomit their cores into the void. This means there could be strangelets, microscopic fragments of strange matter drifting through space like dust. They would be invisible, dark, heavy. They could be drifting through our solar system right now. If a strangelet hits the sun, it would convert the sun. The sun would go dim. It would shrink. The light would go out and the earth would freeze. If a strangelet hits the earth, the ground would boil and we would burn. We would never see it coming. It would be a streak of heat in the sky, and then the end of the world. You might ask, if this is possible, why hasn't it happened yet? The universe is old. Surely a strangelet would have hit us by now. This is a comforting thought. The fact that we are here is evidence that strangelets are rare. Or maybe it is evidence that strange matter is not stable outside of the high pressure of a star. That is the hope. Most physicists believe that without the crushing gravity of a neutron star, strange matter would simply decay back into normal matter. It would be harmless. But most is not all. The mathematics allows for the possibility that strange matter is stable at zero pressure, that it can exist in the vacuum, that it is a floating mine waiting for a ship. And here is where human hubris enters the story. We are not content to wait for the universe to kill us. We are trying to make the monster ourselves. In our particle accelerators, the relativistic heavy ion collider in New York, the Large Hadron Collider in Geneva, we smash atomic nuclei together at almost the speed of light. We create temperatures and pressures that have not existed since the Big Bang. We are trying to recreate the conditions of the early universe. We create a quark-gluon plasma, a soup of free quarks. Before these machines were turned on, there were reports, safety assessments, calculations. The public panicked about black holes. They thought the LHC would create a black hole that would swallow the Earth. That fear was mostly nonsense. Black holes evaporate. But the fear of strangelets, that was more subtle. That was a real question in the physics papers. If we smashed lead ions together with enough energy, could we accidentally create a stable strangelet? Could we distill a drop of the poison in our own laboratory? The official report said the probability was negligible, not zero. Negligible. They argued that because cosmic rays smash into the moon with higher energies than the LHC, and the moon is still there, we are safe. If strangelets were easy to make, the moon would have been converted billion of years ago. This is a good argument. It is the reason I sleep at night, but it relies on the assumption that our machines are doing exactly what nature does. It relies on the assumption that we haven't found a unique way to break the rules. I remember the Trinity test, the first atomic bomb. Before we pushed the button, there was a calculation, a concern raised by Edward Teller. He suggested that the heat of the fission bomb might be enough to fuse the nitrogen atoms in the atmosphere. He feared we would set the air on fire, that the atmosphere would become a chain reaction and the oceans would boil. We checked the math. Hans Bethe checked the math. We decided it was impossible. The probability was near zero, so we pushed the button, and we were right. The world did not burn, but we were willing to take the bet. We were willing to gamble the existence of the biosphere on a calculation. Strange matter is the ghost of that gamble returning to haunt us. It represents the ultimate fragility of our existence. We tend to think of matter as solid, eternal, unchanging. We think a stone is a stone, but physics tells us that a stone is just a temporary arrangement of energy. It is a metastable state. It is a house of cards waiting for a breeze. The fact that the universe has not converted into strange matter suggests that the barrier is high. It suggests we are safe. But it also suggests that we are living in a universe that prefers death. Think about the philosophical implication. Normal matter, the matter that makes up life, stars, water, love, is imperfect. It is complex, it is energetic, strange matter is perfect. It is simple, it is dead. The universe has a preference for the simple and the dead. Life is a struggle against the laws of physics. We are fighting to maintain our complexity. We are fighting to stay normal. And there is a substance out there that represents the ultimate surrender. To become strange matter is to give up the struggle, to relax into the lowest energy state, to become one with the gray goo. There is a solution to the Fermi paradox hidden here. We look at the stars and we see no aliens. We hear no radio signals. We see no empires. Why? Maybe civilizations eventually discover strange matter. Maybe they build a collider that is just a little too powerful. Maybe they try to harvest the energy of a neutron star, and they make a mistake. They drop the vial, and their planet goes silent. It doesn't explode. It just changes. It becomes a heavy, dark sphere, invisible to our telescopes, a graveyard of perfect matter. Perhaps the galaxy is full of these spheres, silent monuments to civilizations that flew too close to the sun. We are looking for Dyson spheres, giant structures around stars. Maybe we should be looking for strange stars, dead worlds that were once like ours. It would be the ultimate irony. The quest for the fundamental theory of matter leads to the destruction of matter. The curiosity of the scientist becomes the executioner of the species. Let's look deeper into the mechanics of the conversion. It is not instantaneous. If a strangelet hit the Earth, it would take time. The strangelet would fall through the crust, eating its way to the center of the Earth. It would settle in the core, and it would grow from the inside out. At first, we would notice nothing. Then we would detect a massive increase in neutrinos coming from the ground. Then the earthquakes would start. As the core converts, it shrinks. The Earth would begin to implode. The crust would crack. Volcanoes would erupt everywhere. But the lava would not be normal rock. It would be changing. The heat would rise. The oceans would boil away into steam. And then the steam would burn. The atmosphere would be stripped away. And finally, the crust itself would fall into the growing sphere of strange matter. It would be a slow, agonizing death for the planet, a fever that consumes the world from the heart outwards. And there would be nothing we could do. We could not drill down to stop it. We could not nuke it. We could not escape. We would simply have to wait for the floor to turn into fire. This is why I say the universe is a loaded gun. We are playing in a room filled with explosives, and we are lighting matches to see better. We call it science. We call it progress. And it is beautiful. It is the noblest thing we do. But we must never forget the danger. We must never forget that the laws of physics are not there to protect us. They are indifferent. They will allow the conversion of the Earth just as easily as they allow the orbit of the Moon. They do not care if we are carbon or quark soup. Is strange matter real? We have candidates. There are stars, RxJ 1856, 3C58, that look like neutron stars, but they are too small, too cold. They might be strange stars. They might be massive balls of this killer substance, sitting in the dark, proving that the hypothesis is true. If they exist, then the gun is loaded. If they exist, then the strangelets are out there. And what happens if we find one? What if we send a probe to a neutron star and bring back a sample? It would be the ultimate energy source. You could feed garbage into a box of strange matter and generate massive heat. You could power the world with a teaspoon of it. It would be the philosopher's stone, the solution to all our needs. But the containment would have to be perfect. One leak, one crack in the magnetic bottle, and the power plant becomes the epicenter of the end. Would we take the risk? Of course we would. We are humans. We always take the risk. We took the risk at Trinity. We take the risk at CERN. We are a species that would rather die knowing the truth than live in ignorance. We would build the power plant. We would study the sample. And we would trust our engineering to hold back the apocalypse. There is a terrifying symmetry to the universe. The things that can save us are the things that can destroy us. The nuclear force gives us the sun, but it also gives us the bomb. The strange matter could give us infinite energy, but it could also give us infinite silence. We are walking a tightrope over a canyon of fire, and we are running. So look at the ground beneath your feet. It feels solid. It feels permanent. But it is just a temporary arrangement of up and down quarks. It is a mask. Beneath the mask, there is a desire for change. The atoms in your body are yearning for a lower energy state. They are yearning to be strange. Only the fragile barrier of physics holds them back. We are living on borrowed time in borrowed bodies, made of matter that is secretly trying to kill itself. This makes every moment of existence a victory. Every second that the Earth remains blue and green is a triumph over the thermodynamics of the void. We are the anomaly. We are the improbable structure that refuses to collapse. We should not be here. The perfect state is a dead gray ball. The fact that we are complex, messy, breathing, thinking beings is a rebellion against the natural order. So when you fear the virus or the war or the asteroid, remember that those are the small threats. Those are the threats we can fight. The real threat is written into the fabric of the universe itself. The real threat is that we are made of the wrong stuff, and the universe is waiting to correct the mistake. But until that correction comes, until the strangelet hits, we are here, we are normal matter, and we have the capacity to understand the danger. We have the mind to calculate the risk. And that is something strange matter will never have. It has stability, but it has no soul. It has perfection, but it has no dreams. We are the imperfect, unstable, dreaming dust of the cosmos, and I would rather be dust that dreams than a perfect sphere of silence. End of transmission.